MAT 1033, review for test 3, and we're starting at question number 22. We have a quadratic equation to solve, and we will solve this one with the quadratic formula. It is in standard form, has the 0 isolated, so we will pick off the A, B, and C. A is 3, B is 2, and C is negative 33. Let's write the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Then we will plug in. So negative b, so the opposite of b is 2, so it will be negative 2 plus or minus the square root. B squared will be 2 squared minus 4 times our A, which is 3, times our C, which is negative 33, all over 2 times 3. Then we will simplify. So x equals negative 2 plus or minus 2 squared is 4, and here we have 4 times 3 is 12, and 12 times 33 gives us 396. The two negatives give us a positive 396 all over 6. And we'll keep simplifying, and this gives us negative 2 plus or minus a square root of 400, which is a perfect square, over 6. So this is negative 2 plus or minus square root of 400 is 20 over 6. And we will simplify here with the math. So negative 2 plus 20 would give us 18 over 6. Which is 3, and negative 2 minus 20 will give us negative 22 over 6, which we can reduce. They have a common factor of 2. This will give us negative 11 over 3. So our answers are 3 and negative 11 over 3. We'll just put those answers in solution set symbols to hold them together. From smallest to largest. Problem 23 is also a quadratic equation that is in standard form, and we will use the quadratic formula for it. So our A is 2, our B is 9, and C is 5. So we'll write our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Then we'll plug in x equals negative b, so that will be negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 5 all over 2 times 2. Then we'll simplify. So we have negative 9 plus or minus the square root of 81 minus 40 all over 4. And this gives us negative 9 plus or minus the square root of 41, which will not simplify, over 4. So we can actually leave our answer here. There is no simplification to do. Problem 24 is an equation, but it is not in standard form. So we will first change it to standard form, get a 0 on one side. So we'll keep the 2p squared. We'll subtract a p. We'll add a 3. And that will equal 0. And then we'll pick off our coefficients and use the quadratic formula. So our A is 2. Our B is -1. Our C is 3. Our quadratic formula is, I think I'll write it up here so that I can have more space. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug into it. So x is equal to -b. So b is -1, so it will be a +1 plus or minus the square root. B squared, so -1 squared, minus 4 times a, which is 2, times c, which is 3, all over 2 times 2. Then we'll clean up. So x equals 1 plus or minus the square root of 1 minus 8 times 3 is 24. You might notice you're going to end up with a negative under that radical. It's going to give you a complex number. So you're going to have an I there. So we have 1 plus or minus the square root of -23 over 4. We will take the I out. X equals 1 plus or minus I times the square root of 23 over 4. And this doesn't simplify anymore. So that gives our two solutions. 1 plus the I square root of 23 over 4 and 1 minus the I square root of 23 over 4. For problem 25, first we will need to go to standard form. So we need to get the 80 over. So we have 2k squared minus 6k minus 80 equals 0. Now we're in standard form. If you notice, you have a common factor of 2 on the left-hand side. We are allowed to divide that out. So we'll divide both sides by 2. This will give us k squared minus 3k minus 40 equals 0. Right, now we'll pick off our a, b, and c. So our a is 1. Our b is -3. And our c is -40. So we'll plug those into our quadratic formula. So our x or our k is equal to -b. So b is already negative, so that will be a +3 plus or minus the square root of -3 squared minus 4 times our a, which is 1, times our c, which is -40, all over 2 times 1. We'll simplify. So we have 3 plus or minus 3 squared. -3 squared will give us 9. You have 2 negatives underneath, which will be a positive. And 4 times 40 is 160 over 2. This is going to give us a perfect square under this radical. X equals 3 plus or minus the square root of 169 over 2. Square root of 169 is 13. So I'm going to just keep going across. I'm getting in a little trouble here. For space, so 3 plus or minus 13 over 2. So first we'll do the 3 with plus. 3 plus 13 is 16 over 2, which gives us 8. And then we'll do the 3 with minus. 3 minus 13 will give us -10 over 2, which will give us a -5. So we end up with two solutions on -5 and 8. Problem 26 also needs to be changed to standard form. So I'm going to move the minus 4m squared to the other side. That will make a 4m squared. And I will put it in descending order. Minus 6m minus 11 equals 0. Pick off my a, b, and c. A is 4, b is negative 6, c is negative 11. So my x equals negative b. B is already negative, so that will make it a positive 6 plus or minus the square root of b squared. So negative 6 squared minus 4 times a, which is 4, times c, which is negative 11, all over 2 times 4. Then we'll clean up. 6 plus or minus the square root. Negative 6 squared gives you 36. You have two negatives, that will be plus. And 4 times 4 is 16 times 4 gives us 176. We're not going to get a nice square this time. And 2 times 4 is 8 in the denominator. So we'll keep cleaning up. 6 plus or minus the square root of 212 over 8. And then I'm going to work on that radical a little bit on the side. So 212, if I go to primes, the only thing I can think of that goes in there is a 2. So 2 times 106. 106 is still even, so I can do 2 again. And 2 will go 53 times. So that is how it's going to simplify. It does have a square in it, so we can take out a 2. It will leave the 53. So we have x equals 6 plus or minus 2 on the outside of the radical times 53 over 8. Now we can simplify a little bit on the outside of this radical. These are all even, so we can divide by 2. So 2 will go into 6 3 times, plus or minus. 2 will go into 2 one time. You don't have to write it, so just write your square root of 53. And 2 will go into 8 4 times. So our answers are 3 plus square root of 53 over 4 and 3 minus square root of 53 over 4. Problem 27 says the bottom of a ladder must be placed 4 feet from a wall. The ladder is 10 feet long. How far above the ground does the ladder touch the wall? This is giving us a right triangle problem. So if we have a ladder is placed 4 feet from a wall, and this is our ladder, and it is 10 feet long, and this is 4 feet from our wall. Pretend that's straight. And it says, how far above the ground does the ladder touch the wall? So what you want to know is this distance, right? We can use Pythagorean's theorem on this triangle, which says a squared plus b squared equals c squared. When we label our triangle, we know the c on this one. It's our hypotenuse, which is 10. The other two sides, the legs are a and b. It doesn't matter which is which. So I'll call the a 4 and the b is our unknown. So we will just plug into our Pythagorean's theorem. So we have 4 squared plus b squared equals 10 squared. Work out all you can. 4 squared is 16 plus b squared equals 100. Subtract your 16 from both sides. So b squared equals 84. Take your square root. You don't want b, you don't want b squared, you want b. So b equals plus or minus the square root of 84. It's distance, so we're going to want the positive square root there. So b is equal to the square root of 84. You can put this one in your calculator because in the directions they said round your answer to the nearest tenth. So when I punched it in my calculator, and I'm going to change to approximate here because we are going to round, it is 9.165. To go to the nearest tenth, this spot, you would look one to the right. So the 6 is going to push the 1 up. So we will have 9.2 feet will be our B.